All right. So, what's up? My name is Braden or Waki. I run this channel with a dude named Joe. We will be posting on here daily. Um, Today we're gonna be reacting to a video called "The Fear of Space." So, let's just go ahead and get into it. If it doesn't, glitch out, which it looks like it's gonna be doing. There we go.
This footage is the first ever recorded footage of the Earth from space. As the image distorts and you're felt straying away from the planet Earth, a certain consternation is felt, almost like you fell into a deep pool of water and you're slowly straying further away from the surface, straying away from what is known, from what isn't nothing. Whilst this footage is nothing spectacular in the world of astronomy, it highlights the feeling of impending terror that space portrays. Its vast emptiness is more than just lonely, it's constricting.
Um, Let me make sure my audio is correct. I will be back. Sorry about that. My that was probably loud, so my bad. But yeah. Is it gonna play? There we go.
Seeing the pure and utter powerful size of empty space in our universe is so perplexing that it twists my throat into circles. It's as if the universe is slapping us in the face saying, your simple body couldn't possibly dare to imagine the sheer size and complexity of my creations. And it would be right, because the truth is, space is horrendously scary.
I mean, he's not lying. Space, if you really think about it on like a deep level, space is so like big that you there is no possible way that we can explore all of it. It will there is so much out there that we don't even know that exists. And it's almost impossible to imagine how much is really out there. But don't be lagging again. Need to stop pausing.
Scary. It is until you compare the planet Earth to others that you realize we have a perfect planet. Jupiter, a gas giant. A planet made of thick, never-ending storms. There is no surface on Jupiter. Its massive scale consists of deep, heavy gas. You cannot land a probe on Jupiter because it will fall into the gas for days until it is burnt and crippled, essentially getting dissected by air. I'm sure the raging red spot of the storm on Jupiter is nothing new to anyone watching. A storm that has lasted for at least 400 years and potentially longer. A storm that itself spans a wider distance than the Earth itself. Imagine a heavy raging storm bigger than the Earth, all of which is heavy gas ripping anything near it apart. A storm so big that it puts our Earth to shame. Everything that we know, love, see, feel, smell, and think all exists on planet Earth. And the fact that a storm, just a storm, on another giant planet puts our entire existence to shame is embarrassing.
I gotta add. That's gonna be a bitch.
Shame is embarrassing. Similar patterns can be seen with Saturn and Neptune, the other two gas giants in our solar system. Worlds of nothing but storms and chemical reactions. Storms that can reach up to 1,000 miles per hour. Storms that would tear your muscle fibers off one by one. But the scary thing is, this is just one example of one planetary system. Space is chaos, but there are more than trillions of planets, many more each with their own chaos. The sheer complexity of size of planets in just our galaxy alone makes you think, what other monsters are lurking in the shadows, indulging in heavy sighs and chaos on the daily? What is happening behind the scenes in our universe? The sheer size of some of these planets and the chaos that each and one of them participate in is actually quite spectacular. But if you think planets even shine as much of a laser pointer on the unbelievable backdrop of our more intense celestial objects, you would find that you are catastrophically naive. Because ultimately, our bigger celestial counterparts shine and behave so drastically intense that they themselves are making a statement to the universe that they are the definition of power. A star, as we know from our sun, to put simply, is a luminous ball of gas composed of mostly hydrogen and helium held together by its own gravity. Stars are unbelievable. They shine for eons and create a habitable zone for planets to play. Stars are the reason we are alive as humans. Without our sun...
Sorry I'm being so quiet. I'm just like really locked into this video. But y'all let me know what y'all think about space and shit. But yeah.
We wouldn't even be close to existing. The sun is incomprehensible, and most stars are incomprehensibly huge, millions of times bigger than the Earth. Sometimes I feel the numbers don't really portray how big the sun truly is. Like, okay, who cares? 1 million times bigger. Yeah, I get it. Woohoo, big sun. So I always feel that a visual representation is a proper way to show the true scale of these things. This is the Earth comparable next to the sun. All I felt when seeing this is fear. Again, that is everything we know and love on one speck of matter compared to the sun. Ridiculous sizes like these are what lead my fear of space. But what if I were to tell you that the sun is unbelievably small, laughably small, so tiny that it seems like an atom in the eyes of the even bigger?
Yeah, our sun compared to other stuff in the universe, bro, is so tiny.
What I'm about to show you is an image that evoked a sense of hopelessness and fear inside my soul. It's an image of the sun compared to one of the biggest known stars in the observable universe.
I guarantee it's gonna be Oi Scuddy.
U-Y Scooty.
He pronounced that so wrong, but I was correct.
The pure monstrosity-like sizes of these celestial objects is unfathomable. To see the size of our Earth alone compared to something like the sun and still have the biggest thing in our solar system be dwarfed significantly is a statement once again from the universe that we are nothing. UY Scooty is 325 million miles deep. Yes, 325 million miles of nothing but a hot hydrogen and helium pool of convection and radiation. If you were to somehow construct a suit that would allow you to safely go deep into this massive star, you would most likely feel that at a certain point, the star itself is the new universe.
For a star to be so big and so wide to where if you get so far into it, it pretty much turns into the new universe, that's crazy. Like, imagine just falling for the rest of your life eternally, just in Oi Scuddy, for example. It's just, you're there forever, just floating. And eventually, just nothing is there besides hydrogen and whatever it's made out of. Man, it's just gonna start freezing up again. Gotta love it. You gotta love it. Well, let's see how long it takes.
Massive star, you would most likely feel that at a certain point, the star itself is the new universe. The universe doesn't mess around with size, because even what you just saw, UY Scooty the star, is absolutely tiny. If you compare it to things like Ton 618, the biggest black hole, or S5 the quasar, it isn't even a speck of dust. Trying to conceptualize and explain size any further than this is absolutely pointless, as our feeble brains cannot give it the actual justice that it deserves. For a couple quick mind-wrecking references, you can fit our entire solar system all the way out to the orbit of Neptune, which is measured to be roughly 80 astronomical units wide inside of Ton 618 32 times laterally. And for one last quick comparison, Ton 618 is 2,606 astronomical units wide. Now, if we compare that to just 1% of the diameter of a galaxy, you could fit 23,000 Ton 618s laterally inside just 1% of the Milky Way galaxy. And I'm sorry to completely kill your ego, but the Milky Way galaxy is a feeble, useless speck of nothing in comparison to the clusters, which are nothing compared to the superclusters, and so on. But let's step away from size, because it's obvious that our universe is huge, but on the other hand, it's actually quite breathtakingly beautiful. While we might not understand the scale of it very well, I think everyone can at least acknowledge the beauty of the stars we see in our night sky. Everyone has had at least one experience of looking up at the stars at night and just admiring them. But the problem doesn't lie in the stars. Ironically, few people dare to realize the strikingly obvious monster that lies right next to them, right in front of our eyes at all times. 2.5 million light-years is the space between our Milky Way galaxy and our closest neighboring galaxy, Andromeda. Let's imagine we wanted to travel to Andromeda. It takes light 2.5 million years to travel between our galaxies. That scale is freaky. So are there any pit stops you can take on the way? Nope. Is there anything at all? Nuh-uh. It's all gas and vast open space. Once you leave the Milky Way galaxy, you are met with a dark, cold, vast space of nothing for 2.5 million years. Pure darkness. The reason this idea of pure vast nothingness scares me so much is because of how our brains work. We cannot handle the thought of essentially nothing, and the vast dark spaces between celestial objects is the closest thing you can get to nothing. I'm not just talking about the spaces between galaxies.
Well, I just got to do a little check on OBS.
Either. Even the spaces between stars inside the galaxies are so vast that it's incomprehensible. Vastness has a certain taste to it. It's not bitter, it's not sweet at all. It doesn't really taste like anything but fear. It's kind of like the fear of the ocean and the massive unknown drop-off cliffs in the deep sea. However, space is much bigger, and the drop-offs never end. And it's not so much unknown as it is lonely. Because the truth is, space is horrifically lonely. Every single part of it. Just like the sun versus the UY Scooty picture, I want to show you a picture. A picture that perfectly describes what I'm talking about. It's a picture of what is commonly referred to as a super void. This is Boots Void, and for reference to scale, it is 330 million light-years across. 330 million light-years of essentially nothing. Boots Void makes up for 2% of the entire universe. 2% of the universe is a deep, unknown void of nothing. Fear, dismay, and discomfort is all I feel when imagining the center of such things. What is in that void? Why is it so lonely? That vastness is crippling. Everything in space is this vast, separated by long distances of nothing.
Why is it that empty, though? You gotta think about that. There's just so much surrounding it, and then that's just empty. There's nothing. Like, why is that just empty, you know?
Distances that we as humans couldn't possibly dream of crossing. Invisible barriers that laugh in our faces and spit on our spacefaring dreams. And to add to even more of the hopelessness to this already seemingly depressing fact, everything is growing farther apart as we speak, because the universe is constantly expanding. And as the universe expands, like a balloon, everything in it stretches and becomes farther apart. And at certain points, these voids will grow so big and the universe will expand so far that we won't even be able to reach another galaxy, as it will be moving away too fast for us to catch up. So the only thing we will have is ourselves, surrounded by an infinite and seemingly growing void that advises us to stay where we are. But we may plead and ask for mercy from the universe, But it won't stop, and over the course of billions and trillions of years, the universe will grow, and it will wait. And while the scale of vast empty space is scary in and of itself, as the universe continues to trudge through time with no stoppage, not only will the distances become a problem, but everything else will too. Because with enough time, everything will slowly start to burn away. The stars and the black holes and planets all have a limited amount of energy to burn. Once the universe starts its clock, it doesn't stop, and it waits. And the true and perfect horror of the universe becomes time.
Me personally, when I think about like how the universe is gonna end and like how the world's gonna end and all that, I just can't comprehend it. It's just too much to think about.
13 billion years is the age of our universe. In our age, we were luckily born in an era of rampant star growth and intense celestial events. We are observing and participating in the universe's first steps, but unfortunately, it will likely never be this way again. According to the heat death, or also called slow death theory, the universe will continue to expand, and as it expands, everything will continue to prosper. Over time, however, and I mean a long time, the raw materials required to make stars and black holes and everything alike will be exhausted out into empty space, into colder and wider areas where it's not possible for hot and dense star formation to occur. And once the universe gets to this point, it will face a poisoning demise, where star formation will come to a halt. It will be faced with the intense reality that it will meet a cold, dark death. But this will take a really long time to happen, right, SPDS, right? You couldn't be more right. In fact, I would argue that the scale of time is the most brutal one, because with this scale, infinity is no longer a concept, it's a derivable truth. But some objects will meet their demise much faster than others. Consider supergiant stars. You would think the biggest stars would last the longest, right? Well, actually, they live the shortest lives due to their intense gravity and unstable nature. They're likely to explode and go supernova or exhaust their energy at a very fast rate. They could even become black holes through the right conditions. These are likely the first things to say goodbye to. Most things like supergiant stars and most other celestial objects will decay fairly quickly in the grand scheme of things. However, there are 3 celestial objects that will hold on much longer. 3 objects that will face the void head on. So I would like to introduce you to our candidates for eternity. The brave heroes that will valiantly trudge towards the end of the universe. The final objects that will make a stand once all star formation stops. Firstly, we have black holes, the fan favorite. These stubborn balls of theoretically infinite density will be one of the last standing celestial objects ever. Second, we have the underdog white dwarfs. These stars are the remnants of great stars that exhausted most of their energy and just remain as pitiful ancient balls of gas that emit so little energy due to their low luminosity and low size. Thirdly, we have black dwarfs, the final product of a fully exhausted dwarf star, a ball of gas that will likely turn into almost solid iron. More on these guys later because they will prove to be very important. According to physicists, it is estimated to take upwards of 100 trillion years into the future for all star formation to stop and all raw space material exhausts into nothing. So let's begin our thought experiment there, when all star formation comes to a halt. Let's start with white dwarfs. According to physicists, white dwarfs can actually burn for trillions of years as well, and the smallest and most low output ones could possibly survive for up to quadrillions of years. But eventually they will die, likely going supernova or possibly turning into a black dwarf. You probably see where I'm going with these guys. This timescale is unbelievable, but we are just barely scratching off the tip of the iceberg. Because the truth is, I lied. White dwarfs are easily taking last place here, and it's not even close. While they ran a good life, the true race between black holes and black dwarfs begins. Black holes are what I view as endgame objects, because they're so intimidating and so scary for good reason. These ridiculous balls of mystery are so dense and so heavy that having them decay is like telling a kid with ice cream to throw it in the ground. Nearly impossible. But as all things have to, these too will eventually decay. According to Hawking radiation, black holes decay, but just very, very, very slowly. Picture it like this. According to quantum physics, there are 2 particles constantly popping in and out of existence on a normal basis. Antiparticle and a normal particle. I know this sounds crazy, but bear with me. Now, if these particles were to pop in and out of existence right next to a black hole's event horizon, theoretically, one of the particles can get sucked into the black hole whilst the other will perfectly and barely escape. This actually makes the black hole lose an ever so slightly minuscule amount of mass, so tiny that it will never be noticeable for trillions of years. But they do decay, and that's important because infinity doesn't care. As long as they decay at all, their fate is all the same. The theoretical amount of time it would take for a black hole to decay under these rules is scary. The time would be roughly somewhere between 2 times 10 to the power of 93 or a Google years. This is ridiculous, because at this point in the universe, everything else would have decayed, galaxies would have dissipated, stars would have all died. Everything would be gone and forgotten, except these black holes that are silently buzzing towards the end of time. So I actually lied. Black dwarfs aren't even in the picture of black holes because they don't even come close. In fact, they will last so much longer than black holes that it is actually embarrassing for the black holes to even try to compare. Black dwarfs are pretty much a fully dead white dwarf. These guys are on the final stage of a star, completely exhausted. They do decay, but it's so insignificant that it's almost immeasurably small. These guys give off almost no heat or light, and they are ancient. These poor guys will have to endure for so long, and eventually they will have to go supernova. But the timescale that it will take for this to happen is paralyzingly ridiculous. So, let's take a journey into the unfathomable for one last time, as we watch the final stand of black dwarfs and their statement to the universe. I know this sounds like science fiction, but these stupid little stars will theoretically exist for 10 to the power of 32,000 years once everything else is gone. That is 32,000 zeros. All of that once everything else in the universe has already disappeared. The universe will be single-handedly vacated by these black dwarfs that separate each other with unbelievable distances. These cold, baseless, almost pointless stars will float through the rest of existence as the final stand of our universe, as the last form of tangible entropy, as the remnants of us and what we once had. Eventually, however, these stars too will die and go supernova. After an almost infinite amount of time, these poor celestial statements will be put to rest with a tiny but infinitely powerful bang that will light up the universe once more as it once was, almost forgettably infinite ago. As the final black dwarfs go supernova, their fireworks throughout the vast wasteland of nothing will give hope to a potential new beginning. But as the universe has always done, it will wait, and it will watch as these ancient remnants of the past give way to the final ending of our reality. It will watch as the final black dwarf explodes and opens the path to eternity. Because from the beginning of time, the universe has waited. It has waited so patiently from its conception. It has waited for the first stars, the first planet, planet Earth. It has waited for you, waited for your bus stop, waited for your life, waited for all the stars to die, all the black holes to die, all the black dwarfs to die. It has waited all the same. And on a much...
Alright, well, I'm gonna end it off there. This was a pretty good video. Let me know what y'all think about it in the comments. And I will see y'all next time. So, peace out.